Hey, Mr. Allred here, and we've been working with rational exponents, and one point I want to prove is that you can do anything with rational exponents as you can do with regular exponents. And you can turn roots into rational exponents, so you can do anything with roots and exponents in rational exponent form. So we've got some practice problems here. The first one is x to the 2/5, and that is over x to the 2/7. So we have an x on top and an x on bottom. So as far as exponent rules, we can subtract the two exponents. So x to the 2/5 minus 2/7. Now, unfortunately, with fractions, we need a common denominator. So if we're going to clean this up, 5 and 7 would have a common denominator of 35. So I'll multiply the first one by 7, so that'd be 14 over 35. I'll multiply the second one by 5, so that'll be 10 over 35. So this will be x to the 4/35. So that is to the power of 4 and the 35th root. Okay, doesn't mean it's better, just means we can do it. Here, the second one. I have the quantity of 5x to the 1/2 raised to the 7/3. Now, since I have an exponent on the outside of the parentheses, I can push that into each part. So I will have 5 to the 7/3, and I will have x to the 1/2 times 7/3. Because when we raise a power to a power, we end up multiplying. So let's see here. I can write the 5 to the 7/3 as the cube root of 5 to the 7th. And we might clean that up a little bit more. And then when I multiply here, I'll have x to the 7/4. I could leave it like this, but let's see. I can pull out some 5s. I need roots of 3, and there's 7 of them, so I can pull out 2 5s, and there would still be a 5 under, and an x to the 7/4. So I could write this as 25 cube roots of 5 times x to the 7/4. And usually I'll write a number as a root instead of an exponent. Now if you're going to just get an approximation, go ahead and go to your calculator and throw that in as 5 to the 7/3, because that'll be just as good. The third one here, the last one, I have on top of a fraction 6x to the 4th y to the 1/2, and then the denominator 2x to the 1/2 y to the 3rd. So just making sure we see like things. 6 over 2 are alike. Then we have the x's are alike, where we'll subtract exponents. And then we have the y's that are alike, where we'll subtract exponents since it's a fraction. But, catch up here, buddy. I will have 6 over 2 is 3. Then I'll have x to the 4 minus 1/2. And I'll have y to the 1/2 minus 3. We can make those common denominators really easy. So I have 3x to the 7/2. 4 is 8/2, so 8 minus 1 is 7. And then y to the negative 5/2. 3 is 6/2, so 1 minus 6 is negative 5. Here, I don't like negative exponents. So the 3 and the x to the 7/2 can stay up top. The y to the negative 5/2 will go to the bottom as y to the positive 5/2. So in the end, my answer will look like 3x to the 7/2 all over y to the 5/2. Thank you.